Ma'am, I hope you can see. Is it visible, ma'am? Hello? Hello?
Yes, ma'am, it's visible.
Yeah.
Yeah.
The screen is fine, no, ma'am. I think, should I
It's
change
fine.
any
You can make
settings?
it full screen. Now, slide is visible.
Yeah. Let me check one second. I shared Windows, ma'am. Is it fine? You asked me to see. Is it okay now?
Yeah, it's okay, ma'am. Now we can start the slideshow.
Yeah. Okay. Thank you, ma'am, and welcome all of you for this 5 days faculty development program. Today, I'll be talking about sustainable cement concrete pavements using construction and demolition waste. So I didn't write my name as doctor just because I just completed my defense day before yesterday. So still my name, I put it as Reshma only, though ma'am is written as doctor. So today's presentation, I'll be talking about my studies only, whatever I have done for my research. So what is the need of the study and the literature review, whatever I have done, the research gaps and the findings from the research literature, then materials and methodology adopted, investigations and test results. So finally, results, discussion and conclusion. This will be the outline of my presentation. And when I'm talking about sustainable pavements, there are two associated terms with it. It's a main word is construction and demolition waste. So construction and demolition waste you can define in many ways. So just simple definition I've given here. It's any waste generated during construction, or it can be due to demolition or remodeling of any civil engineering structures like pavements, bridges, or flyovers. It can be buildings or anything. But for my studies and today, whatever I'm talking about, that is only with respect to recycled concrete aggregate, because construction and demolition waste, it includes many other materials also, but here we will be concentrating only on recycled concrete aggregate. So when I'm talking about construction and demolition waste, we should be understanding what is a quantification in India. So here we have the data only till 2013. That is, I got it from ICI workshop, which has happened in 2016 at IIT Madras. So this is the most of the papers. If you see, you can see this table. This is the only quantification.
Ma'am, the
Yes.
slide is moving or not? You have started the slide,
Yeah. Yeah.
but I'm seeing only the first one.
Second slide. It's third slide.
Can anybody respond? Anybody can see the slide moment? Anybody please respond? Meena Kumari. Somebody has raised hand. Meena Kumari.
If anybody is near, you just ask
Slide is
them,
not
ma'am.
moving, ma'am. I think window is not shared. Slide window is not shared. Maybe
Window only I
Now
shared.
it's changing.
now it is okay. Now it is fine.
Now it's
Now it
working.
is fine.
Now it is okay. Yes, ma'am. Now it is okay.
So
Yes.
I think in a slideshow it is not getting show. This is not a slideshow. So I'll just go by this only then.
Okay, ma'am. Then.
Now the slide is changed, right?
Yeah. Yes, ma'am.
Yes.
Yeah, I'll continue. Okay. So this is the only table which you can see in most of the papers. This workshop I had attended at IIT Madras in the year 2016. So this was exclusively for construction and demolition waste, not only for pavements. It is for the any construction, but not only for the pavements. But this quantification says it's 530 million tons, but it's actually underestimate if you and because there are many other studies which is exclusively for quantification of construction and demolition waste in India. So most of the studies or literature says that it is an underestimate. But if I have to put in a slide, I can show only this because literature on this cannot be shown as a thing. That is why I've just showed only this, though it is an underestimate. And this is again from a conference that has happened in VIT Chennai. They have given in city-wise quantification. So wherever you see, it's more on the daily generation or annual generation. It is the construction and demolition is waste is increasing in the increasing order. And when I'm see, my topic is something related to sustainable construction. So whenever we talk about sustainable construction, usually we see 3 R's, that is reduce, reuse, and recycle. Here I have included one more term called recover. That is nowadays in Australia, many this work is going on this recover thing. That is actually a waste from the energy generation from waste. So when I'm talking about recycled concrete aggregate, I may not be able to produce energy from recycled concrete aggregate. But in when I'm talking about construction and demolition waste, there are many other things, say wood and other plastic materials and all. So when you consider other materials other than recycled concrete aggregate, we can talk about recover. But it is only some papers it is only 6%, some papers it is 11%. So it's not much, but this also can be thought of this particular term. Otherwise, the order first thing we should understand. Later, try to reuse. And there is a difference between reuse and recycle, because reuse means as such we should be using. Say construction and demolition waste, I get recycled concrete aggregate. Without processing, it is not possible for me to use recycled concrete aggregate for any of the construction activities. But at the same time, I take some other materials, say wood or the glass or anything. Sometimes it is possible for us to reuse without any processing. So the second aim is to reuse the waste as such, if it is possible. That is without any processing techniques. Next third one is recycle. So it is not possible to reuse as such. We should go for recycle. So this has more importance here. Recycling means some processing techniques. It can be anything, any processing techniques which is suitable for the material. So it can be recycled. The last option is recover. If it is not possible to reuse, not possible to recycle, then we will have to think of recovering the energy from the waste. That is what this 4 R's talk about. Next, one more figure I have written here, that is just to understand the total demand of the aggregates. So total demand of the aggregates is so high that even if we go for recycling of construction and demolition waste, it constitute only 12%, maybe 10 to 12%. And there are and we are using right now we're using natural aggregates more. See here, but still you use natural aggregates, you use recycled concrete aggregates. The total demand for aggregates is so high that in future we will be in trouble, because already we started using M sand, because river sand is not we are not getting river sand. So the reason to use M sand is that. So now in future we may face a situation where we will not be able to go for natural aggregates, because processing the getting natural aggregates, there are many issues, environmental issues and carbon footprint, all those things. So we will have to go for something which is sustainable in nature. That is the best example or a best way to utilize the construction demolition waste in terms of recycled concrete aggregate. So the need for my studies here, whatever research I have done, the need was the main aim was to contribute something to material sustainability. So when we contribute to the material sustainability, we are reducing the environment. It reduces the environmental impact, saves energy, etc., and saves energy in terms of new material production. We need more energy, so that is getting reduced. And the problem with recycled concrete aggregate, I'm just talking about the problem, that is that is the main reason behind this studies. Because the main problem with recycled concrete aggregate is the othered motor, that is residual motor, which is present in the surface of the aggregates. So if you look into construction and demolition waste and look into the recycled concrete aggregate, the main problem associated with this is the motor, presence of motor. And need to establish the factual details of RCA, which is lacking. And later we need to create more awareness among town planners, contractors and other engineers to use this recycled concrete aggregate as in structural applications. Because when you're talking about recycled concrete aggregates or demolition waste, most of them use it for sub base preparation, subgrade preparation, or sometimes sub base also. But it is very few studies says it is for pavement quality concrete. That is for slab PQC. We say for cement concrete pavements, we call it as pavement quality concrete, which is of M40 grade. So that is called structural application. I'm not talking about any other structures. I'm talking about only cement concrete pavements here, which is M40 grade of the concrete. So throughout my studies, I have used only M40 grade of the concrete, which is required, which is a prerequisite for pavement quality concrete, that is PQC for cement concrete pavements. So many developed countries as well as developing countries, they have many techniques to process, and most of the countries are facing problems with uh, natural aggregates. The demand is more for aggregates. And there is a huge amount of C&D waste piling up in outskirts of all the city across India. So whenever you go travel anywhere in India, you could see many C&D waste piled up in the roadside. So there are some rules in 2016. The Central Pollution Board has released some rules and regulations. Zonal wise, segregation collection is required, then segregation is required. All rules have been come, but no, not actually that zonal wise segregation is not happening in real. And it is essential to examine the feasibility of utilization of RCA. So we need to know how much percentage of recycled concrete aggregate can be used without any improvement measures. These are in one word. I have written: resource conservation, waste diversion. These are the benefits of using recycled concrete aggregate, which is already discussed. Environmental impact, to an extent cost savings, because I cannot say it saves money in terms of money, because we are more concentrating on sustainability than cost. Because cost wise, if you say in future, even the cost may increase for recycled concrete aggregate also. So I've done cost analysis also, just show you how much it is getting saved. More than that, we get concentrating on sustainability goals. And we need to talk about circular economy approach also. So when we are talking about circular economy approach, it is something like 3 hours or 4 hours only. The loop has to get closed. Otherwise, the conventional approach is take the natural aggregates, use it, and then dispose. That is take, use, dispose policy. But here it is reutilization is happening. That is why we can close the loop. So circular economy approach has to be encouraged. So whatever literature I have done, I have not put it in slides. It will be boring if I put all the literature which I have referred, because when we are doing a research, the literature review plays a very important role. Those who are currently doing PhD, they'll be knowing it better, because almost all the guides say to their research scholars to do literature review first. But most of us, we don't do literature review in the beginning. We try to formulate our objectives without going through literature search. That is a major problem with most of the research. We will never come to know till one stage of the research, because I've gone through all these things. I'm just sharing my thoughts with you. Because most of the ma'am said most of the people who are attending this workshop is research scholars. So those who are doing research, I just recommend you to genuinely do a very good literature search, so that you can frame your objectives more easily. And when you're framing the objectives with the help of literature search, it will be genuine. You will have a hold on your objectives. Otherwise, we'll have to run around like asking for objectives. How many objectives are required, and what is the way to frame the objectives. That is little difficult. Or till the end of the research, you will be having a confusion: what has to be done, what is not done, what has to be done. So in literature review has to be given more importance. It's just I think for during my research, I have spent for top like say 5 chapters I have. I think I have spent more time on my literature chapter, because each time I write and give it to my guide, he'll not be satisfied. Again, he'll ask me to change. I think 5 times I might have changed. Then I started feeling guilty that I haven't read whole paper. So it's very important. Then after I read the whole paper, then I could get more ideas and more knowledge I could gain. So that is what I just want to tell you, the people who are doing research. Please make sure that your literature search is very, very strong, so that you can have a hold on your subject. You don't have to ask anybody what has to be done next, or how this particular experiment is done, what will be the results, the possible results. Because whenever we do anything on cement concrete, it is heterogeneous in nature. First of all, cement concrete itself is heterogeneous, and on that I am using recycled concrete aggregate. It is even more number of heterogeneity comes into picture. So this literature search is very, very important. So what I found from my literature search is there are distinct physical variations with respect to aggregate properties. That is mechanical properties, say abrasion, crushing, and impact values. Those three are still fine, but the main problem with this recycled concrete aggregates are water absorption. So then you need to see why this water absorption is increasing or it is more. The reason behind this water absorption, most of the literature, they say the reason behind this is the residual motor which is present on the aggregate, which is any aggregate you see, any recycled aggregate you see, some amount of the third motor will be present on the surface. And we cannot quantify. There are many research which quantify the percentage of uh, percentage of the motor, quantity of the motor. It's in actual practice, it is difficult to quantify the adult motor or a residual motor which is present in each aggregate. That is little difficult. So in the main solution for this, I say, is processing techniques. So processing techniques should be very good so that you get a very good aggregate with minimum cement residual motor. And one more thing is, what happens to this recycled concrete aggregate? When I was doing my research in the beginning, I used to go in search of where there's construction and demolition activities, so that I can collect the construction and demolition waste and then manually crush, and then using jaw crusher I can get aggregates which is 20 down, which is required for pavement quality concrete, PQC. When I'm talking about pavement quality concrete, PQC, cement concrete slab, I need 20 down size aggregates. So I had to do some processing. So when I went in search of recycled concrete aggregate, I get some amount of aggregates from one place, one source, and I start doing the experiments. Some point I'll not be able to carry out, because that will get finished, because it won't be sufficient for the next set of experiments which I planned. I feel that is the main problem with this particular study, because most of them, they stop the study by doing only mechanical properties, say compressive strength, flexural strength, and the split tensile strength. Maybe they carry out some more studies. Some papers have seen that is not the problem with the researchers, because the problem with this particular waste, because you take from one source, the properties are different. You take from another source, the properties are entirely different. So I just, by knowing this, I just wanted to take the recycled concrete aggregate from different sources. So that is one problem associated with this. And next, the origin. We never know what grade of the concrete it is, until and unless we have to go ask them what grade you have used, because that is little difficult to get the details of it. And then techniques of recycling facility available in foreign countries. Few countries it is available, and India we have very less recycling facilities available. The one which the first recycling plant is in Delhi, Burari, Delhi, and here now I think Delhi has two more plants. Together they recycle 2,000 tons per day, I think so. And one more we have is in Ahmedabad. So and here in Bangalore, I got to know only after 3-4 years of my research, that one place in Bangalore, they have a recycling plant. Later, I started getting recycled concrete from the same source. Till then, it was little difficult for me to find the source, and then I find different properties from different source. So that is one more problem associated with this. Next is very high water absorption value. Somehow we can compare the mechanical properties, say abrasion, crushing, all those things, but the water absorption is very high. And another very important problem associated with recycled concrete aggregate is ITZ. I think most of you will be knowing what is ITZ. It is interfacial transition zone. So here, when we are talking about normal concrete, we say we discuss more about ITZ, that is interfacial transition zone, because it is little, we just assume it, we think that, or not that we think, it is weak points. And when I'm using recycled concrete aggregate for the concrete production, that that concrete will have two interfacial transition zone. One is only already existing interfacial transition zone, and one more is when I'm mixing this recycled aggregate with a new concrete, one more ITZ will come into picture. So that is the main issue with that. Is another one is water absorption. Another main issue which literature says is this weak ITZ, or I should be telling double ITZ, not weak, as well as there are two ITZ present here. And I just got to know from literature that most of the researchers says 30% or 50% is possible to replace. But it is when I say 30% or 50%, the it material sustainable, in terms of material sustainability, it is fine. But in terms of cost wise, I cannot conclude that 30% or 50% is enough. So there are many papers which says 100% replacement is also possible, but with high quality recycled concrete aggregate. What they mean by high quality recycled aggregates, it's just with respect to the processing techniques. The processing techniques should include something which can remove the maximum othered motor. That is the processing techniques which we need. So new mortar removal techniques are available, pre-treatment techniques are available, adjusting water cement ratio, all those things are tried, and many research is happening. And then for anything to get into the rule, we need some codal provisions, because whenever we go for a mixed design or anything using recycled concrete aggregate, we don't know how to do mixed design. So mixed design guidelines are very, very important, but it is when we use a new materials, how to use, how much to use, and what should be the water cement ratio, and what should be the super plasticizer amount, and what other admixtures has to be added, and what kind of admixtures. There are many super plasticizers available, and which will suit best to RCA. There are many things which has to be studied. And there is one code, that BIS 383 2016, which is considered as a positive step towards initiating the use of C&D waste materials. That was the only one which was available when I started my do. So I had a confidence that okay, this is there in this BIS 383, I can use. But thing is that the BIS 383 says only till the 25% can be utilized. No, that is only till M25 grade. So that is, and again one more IRC 121 in 2017 guidelines. This guidelines is exclusively for pavement. It says up to 30% NCA, that is natural aggregates, can be replaced with uh, recycled concrete aggregates up to M40 grade of the concrete. So the code says 30% can be utilized without any issues. But they say that it is for rural roads. This has to be noted. And in IRC, it says it is only for rural roads. So what they mean by rural roads, maybe because the rural roads, the number of traffic is less, the repetition is less. So it is 30% if you use, it is not an issue. So something beyond IRC has to be investigated. So that is why I started with, this is from IS 383. Here you can see this recycled aggregate. The RCA and RA is there. RCA, recycled concrete aggregate, means it is only aggregate. Recycle, when I'm talking about recycled aggregate, it includes many other particle bricks also. So here only the plain concrete, it is 25%. Here M25 only 20%. Plain concrete, it is 100%. So it cannot be reliable, but there is something which is there in the code to promote the recycled concrete aggregate, I say. And this I've already discussed. Some gaps I find identified, so that I will go with my studies. So extensive sample collection, because most of the papers I've seen only one or two sources they have studied. So I've taken five different recycled concrete aggregate from five different sources in and around Bangalore with different ages of the concrete. And short-term durability studies have been conducted with respect to shrinkage and creep behavior. I wanted to do something related to long-term durability studies, and especially fatigue studies, because fatigue studies are very important with respect to the pavements. That is, what is the resistance to number of repetitions of the load. Next, one more very interesting thing is coefficient of thermal expansion. Today's topic, I don't think I'll be able to cover this the temperature studies which I have done, but I just did not delete this yesterday, just because few people will be doing something related to RCA. For them, they can think of doing this particular area, which is not touched anywhere. Anywhere away. I have not. I have searched enough. I did not get much on the studies of thermal expansion. So people say, when I had a doubt while doing my research. I had a doubt whether I should take this particular objective or not. So I inquired with many people. Then most of them say there will not be any difference of natural aggregates and recycled concrete aggregates. So I was a little reluctant to do this, but still, when I talked to one of the professors in IIT Madras, he is basically doing test on recycled concrete aggregate. He gave a hope, telling that the thermal expansion, the coefficient of thermal expansion, that is when temperatures changes, what is this coefficient of thermal expansion? Obviously, it will change. So the problem with recycled concrete aggregate here is the motor is present. So when the motor is present, the thermal expansion coefficient also will change. So due to that, there will be some changes in the case of thermal stresses also. Just gave a hope. That's why I started doing this particular test, temperature analysis. Because when we are talking about cement concrete pavement, temperature stress is very, very important. You go and search for the cement concrete pavement studies, then you find many papers on load stresses. So similarly, this temperature stresses also should be given equal importance when we talk about cement concrete pavements, as because the thermal stresses are very important. IRC 58 itself, when you design a cement concrete pavement, we have to concentrate on thermal stresses as well as load stresses. So this has some importance with respect to recycled concrete aggregates also. So they just done some objectives. This is just my PPT, which I presented for my thesis. So same thing, I did not get enough time to do some alterations. So just given as such. The objectives, the identification, procurement of RCA, then analyze fresh and hardened concrete properties, optimum utilization. Obviously, when we start replacing from 10%, then 20, then 30, then finally I should be able to get an optimum percentage. So I just tried for optimum, what is the optimum utilization as any other study. And then I try to analyze the result, and then try to relate compressive strength with flexural strength and split tensile strength, the relationship. That is one more thing. Next is durability in terms of resistant to acid attack, and soaptivity and fatigue behavior. Last one is temperature gradient. This I'll not be covering it in today's class. So this is actually the objective was to investigate the non-linear temperature analysis with respect to its depth using finite element analysis that is done in ANSYS software. So methodology I adopted this. I don't have to tell to the faculty members present here. So I'll just skip all those things, what materials we use, all those things. And mix. Then one thing which I have done a mistake is because when my MTech project was something related to urban transport planning, and when I started doing my PhD, I shifted from planning to traffic planning. All those things were my topics. Then when I shifted to started doing PhD, then suddenly I had to study more about cement concrete pavement. So concrete technology, there is a subject called concrete technology, advanced concrete technology in fourth semester as well as seventh semester for us. When we studied, it was in fourth semester and eighth semester. So what I had only that in my mind. Okay, I was not knowing anything about this IRC 44, because when we study transportation engineering, we study this IRC 5837 for flexible pavement, 58 is for rigid pavements, and IRC 44 I was seriously not knowing that I should be doing mixed design as per IRC 44. So initially I have done a mistake not knowing about the codes which is available or only exclusively for cement concrete pavement. So that is a mistake which I have done. So I recommend all the research scholars. So first we should, and even IRC 121, I wasn't aware of it. I was busy doing the laboratory work and trying to cast and get the value, just busy with that without doing more on the background work. So when you're starting your work, it's very important to know all the IRC codes available, not only IRC codes, anything for that matter, anything which is available on that particular topic, and anywhere you find any workshop going on with that topic, you should be able to attend. That will help a lot to get in contact with people who are specialized in this, so that anytime, any point of time you get a doubt, you can mail them and ask, and your doubts will get cleared. Otherwise, you will have to search a lot many papers, and then finally you will be getting confused. So better you can discuss with people who are specialized in this. So you should be identifying that first. That is very, very important, rather than just going to the lab and trying to finish off your work. So first around 6 months or in between when you're doing the work also, you can just go through the code books available, because IRC 121 was new to me. Just because maybe I was not into this cement concrete pavements more. So that code was new to me. Somehow I attended the workshop at IIT Madras, so I could just talk to people and then get to know more things about this construction and demolition waste, and then contacting them. That helped a lot actually during the entire journey of thesis. So I recommend you all, I mean, those who are doing the PhD, please make sure that you know the relevant codes which has to be used. And then the fresh concrete properties in terms of all slum test, this VB consistometer and compaction factor. I've not included compaction factor, but that is also done. But majorly we concentrate only on slum test. And in throughout my work, I have used two terms, that is RL and RJ mixes. So when I talk about RL mix, it is manually crushed. RL means what I have done is I've collected the construction demolition waste from a particular source, and then using with the help of some labor, it is processed into manually processed. It was really difficult job, manually processed to a smaller size, so that I can put that into jaw crusher, which is available in our laboratory. So jaw crusher will give the final product as 20 down size. So that is the way I have used this RL mix. And I'm talking about RJ mixers. It is directly processed from industry, which is situated in Bangalore. So next, in hardened concrete properties in terms of compressive strength, flexural strength, and split tensile strength. Then done a statistical analysis also in order to establish a relationship between the hardened concrete variables. Because that is important. We know compressive strength. You suppose you've not done with flexural strength, we can find out flexural strength if you know compressive strength. So there is a relationship between compressive strength and flexural strength. So in order to develop such kind of relationship between between this the concrete which is used, where we use RCA, have done a statistical analysis that can be done in any platform. Since I was okay with this SPSS, I have done in SPSS. You can do it in any other softwares, even Excel you can do, but Excel the curves is very less. In SPSS, if you see, SPSS is a statistical package for social scientists. So SPSS, if you see, you get 11 curves. So you can just analyze all the 11 curves with respect to all the parameters, say R square value, T distribution, F distribution, anything. You just you can compare it with 11 curves. But when you see Excel, you have only four or five curves. And even MATLAB can be used. So, but it is very important to have a statistical analysis. But if you want to have a statistical analysis, you should be having enough number of data. So you cannot take some, maybe a few data, 10, 20 and all, it is not enough. Minimum some number of data are required. I just written here feasibility, that is, I'm not covering that fine aggregates in this. Next, I'll just go with this. So here, these are the sources, 5 different sources I have collected: 10 years, 15 years building, and 20 years. Then 20, another one from 20 years, another one 5-year-old demolished cement concrete pavement only I've taken very near to our college. So these are the 5 different sources. And these, and then first initially, like every other study, we do the characterization. So here you can see this table. See, water absorption for normal coarse aggregates is only 1.3. When I'm talking about source 1, say it is so high that it is 8.5, I was getting 7.8, 5.6, 4.3, 4.2. So like, and in other material characteristics also, see, it is so high. The IS 2386 part 4 is for all the mechanical properties. It says the 30%, 35, somewhere it is 30, some places it is 35. So all those things, but all the values of source 1, 2, 3, 4, it is more only. Comparatively, I could say that the 5 years old cement concrete pavement was giving better results comparatively. It's not exactly the same as an NCA, but comparatively it is better. One of the reasons to take that as a source is this. Another reason is it was very near to our college. It was easy for me to get the aggregates pack, and then transportation was easy, so I could collect more amount of aggregates. So done. See, for my further studies, I've used the aggregates only from source 5, not used from any other source, only from source 5. And this is the mix which I have done. RL 15 means it is 15% replacement. Say 20% replacement, 25, 30, 40, 50, 70 and 100. This is the percentage replacement I have used. You might think why it is varying. See, I have used 15 here, then only 5% increment, then again only 5% increment, then again it is only 5%, then 30, 40, 50, 70, 100. That is because the initial stages, the methodology was not very properly understood, and I wasn't knowing that the increment should be equal. That was a mistake which I have done. Due to that mistake, I will tell you where exactly that got reflected. So I want all of you to, what was my intention is, when I just wanted to know exactly what is the percentage where I'll get a maximum, the optimum percentage. That was my intention of the giving an interval of only 5%. but I shouldn't have given that. That reflected in later studies. So I think every time it should be the 10, 20, 30, 40, 50, that some uniform interval we should be keeping. And here the water cement ratio used is 0.445. Again, this table is for processed RCA. You can see the processed RCA, the water absorption value is too less. It is 2.2. There it was 8.5%. Here it is reduced to 2.2, 2.3, 2.5. When I'm the sample 1, sample 2, sample 3 means it is from the same source, that is from a recycle concrete plant, but a different like batches I have collected, just to make sure that some kind of uniformity is there. Because when I started collecting from source 1, 2, 3, 4, 5 directly from the sites without any processing, and I have done processing at laboratory, the variation was too much. So I wanted to make sure that the variation is less or more. That's the reason I have taken in batch wise, and then I could find that it is almost same. So I could continue with the further studies. So I'm not talking about the other values. It's just the same as any other values. So I would concentrate only on water absorption. I wanted the water absorption value to be a little less comparatively. So here, since the water absorption is less, I have used only 0.4 as water cement ratio, because the other case, as soon as I pour water to the cement concrete mix, all the motor which is already present will absorb more water, so the water demand was more there. Here, first of all, I use saturated surface dry aggregates. That means first wash the uh, aggregates, then soaked in water for 24 hours, then surface dried, so that the water demand will become less. And I could get a good slump with 0.4 as water cement ratio. So here this is another thing. Most of the papers you see the slum retention also. Not necessarily you have to do the slum retention, because we have many with this things which we can add to concrete, so that the retention is there. So, this retarders we can add, that is there. But still one of the engineers from field, he has a good experience in field, so he just suggested me to go for a slum retention of minimum 30 minutes. So just tried so that the slum retention is good. Otherwise, we say while transporting, slump is getting lost, and then by the time it reaches to the site, the slump is very, very less. It is not sufficient. But this is in the case of pavement quality concrete. We don't need 100 slump. We need only 25 plus or minus 5 slump. That is sufficient. This much, when I'm getting 43 in the laboratory, obviously it will satisfy the field requirements. I've just not linked this. It's my the table which the same table, just put only graph. So 15%, 20%, 25, 30, 40, 50, 70, 100 I've taken. I should have taken 10, 20, 30, 40, 50. I should have reduced my work also, and I should have increased here instead of jumping from 50 to 70 and 70 to 100. I should have taken 60 and 80 here. That would have been a better, I should have got a better results later. So here you can see that the decreasing trend. Obviously, when we use recycled concrete aggregate and we use more and more replacement, obviously it is going to get reduced. But the optimum which I got it is 30% here. The same as what IRC says. But when I was doing this particular experiment, it was before 2017. So it's not that because IRC says it is 30%, I've concluded it as 30%. It is not that. The IRC 121 came into existence only in 2017, and I got to know that only in the year after 1 year. So this studies happened prior to that. So this even
Yes.
structural strength. even flexural strength also, then split tensile strength, everything. Then I'm talking about RJ mix. When I'm talking about RJ mix, you remember it is zero point 0.4 as water cement ratio, high quality aggregates, which is processed at industry. You see the difference we are getting. 50, I did not start from 20, 10, 20 because it is already established that 30% can be replaced with a much inferior quality of aggregates. So obviously, when I'm getting a very good quality of aggregates, I don't have to start with 10, 20 percentage. Just directly started with 30 percentage. Then 50, 70 and 100. Here also I've done a mistake that not increased in a proper way. So the split tensile strength and comparison, all those things started. Then the next one, then relationship. So I said here it reflects actually when I'm not taking a proportional increase there. I'm not. I'm getting cubic. Some three places cubic relationship and here also cubic relationship. So this is a problem. So I feel why I have got this non-proportional or non-linear curves. So when I'm talking about linear, y equal to mx plus c, it's linear. When some compressive strength is increasing, flexural strength is also increasing. When I'm talking about cubic, there is no proper relation, the linearity when this is increasing and this is not increasing in a proper way. So that is the meaning of it. This I feel this is because of the reason which I have not taken a proper increment while replacing. So whenever you try to relate or try to establish the relationship between two different variables, it's always better to take a constant interval. I wanted to relate these two variables. That is the reason I have continued even after getting optimum percentages 40 or 30 and 50 and 30. But still, it's not properly done because many values already I had, but still that proportion has had to be same. This is just a curve fit which I have done in SPSS. You can see here the number of curves: linear, logarithmic, inverse, quadratic, cubic, compound, power, S, growth, exponential, logistic. There are many different curves. Together, you can just do analysis, ANOVA, analysis of variables in SPSS. You get R square value, T distribution value, F test value, and you compare the which is best based on those two. R square value, as all of us knows, it is when it is nearing to 1, it is good. There is a good relationship. So this is just an example I have given. Similarly done for all the other. Then this is some curing methods. Next, just tried because when I did this. Uh, all these experiments, I found that even you can see from this this. Yeah, when you're talking about 100% mix, whether it is split tensile strength or flexural strength or compressive strength, when we compare the two mixes, when we replace 100% RCA with NCA, the problem is it's very less, the compressive strength or flexural strength or split tensile strength, it is really going down. So what can we do to improve the compressive strength? So that is one thing I have done is if cement slurry coating for only for 100% RCA, because all the other I don't want to replace 50%, say 30%, which is always it is better if I can replace the entire NCA with RCA. So it can be like cement slurry treatment is just a trial. So here you can see the difference. See, all the mechanical properties, it is improved. When it is all the values, it is improved. That is because the originally when because of the processing techniques, the weakness and the flows for RCA will be more. And when you are having a cement slurry coating around each aggregate, it acts as a protective layer against the mechanical properties. So that may be the reason that it is increased. Similarly, when I'm talking about even the this property is also improved. And here you can see this here. I've not conducted a split tensile strength because it was little difficult. So I didn't have much more of, I didn't want to continue with this. So I just stopped only doing compressive strength and flexural strength. So here you can see I just increased the cement slurry treatment 2%, 4, 6, 8, and 10. When I reached, it's in an increasing order. So, but I stopped at 10% cement slurry, thinking that if I use beyond 10%, it is not going to be economical. And I cannot say it as a sustainable pavement construction because I'm using something which produces a carbon footprint. So 10%, I've just 10% I've used, and then if I use 12%, I know it is going to increase more. So that is the reason I stopped here, and then, but it is increased. But correct thickness is if you add more also, it is going to get, maybe it will affect in, maybe in the workability issues will be there, durability issues will be there. So here, this is the discussion why it is. So cement coating on RCA can offer benefits such as improved bone strength. It can also have negative impact on slump value due to increased friction, agglomeration, hindered water movement, all those things. That is, but basically we have the aggregates will have a protective coating. So this is again the compressive strength we already showed in terms of table. The same thing I put it in terms of the graph. Next, from this all this initial studies which I have done, I could conclude that when I'm talking about RL mix, I could replace only 30%, and when I'm talking about RJ mix, I can conclude that the 50% can be adopted. That means beyond 50% replacement, the compressive strength is getting reduced. So I cannot say that I can use 60 or 70 or 80. Even after using a good quality aggregates, which is possible to get it from Bangalore recycled plant, I could conclude that 50% can be used without any treatment. And at the same time, with some cement slurry treatment, 100% also can be used. It's not only cement slurry treatment. There are many other treatments. Acid treatment is there to remove this adhered mortar. So many techniques are there. This is one of the techniques which I have used. So whatever studies I have done, because I cannot conduct for all the mixes, it is not possible to conduct all the tests. So I've just taken only control mix where I used only the 100% NCA. Optimum, when I'm talking as optimum, it refers to RJ mix, and it refers to 50% of replacement. And then 100%, because I wanted to know what, because I'm interested in doing something on 100% replacement also. So obviously I need the upper control also. Similar to the lower control thing, I wanted an upper control also. So I've just done for RJ100 also. A modulus of elasticity, obviously it is required. So just compared with IS and ACI values and ultrasonic pulse velocity, just to make sure that the concrete is uniform and it is of good quality. Next, the main thing is durability studies. So the significance of why, and one more very important thing is, when I was just doing, I had initially, when I was giving my comprehensive viva, I had I had an idea that I have to do durability test. But under durability test, when I talk about structural concrete, it is entirely different. And when I'm talking about pavement quality concrete, it is entirely different. So I had a doubt that what kind of durability test I have to carry out. So that is very, very important, that you should know what durability means. There are many, and you cannot go and do all the tests, and then you will never come to an end. So So just to search some papers where they have not touched much on some particular test. Obviously, many people might have done, but still few less. I felt that I had to do this particular test. That's why taken this particular test, sulfate attack test. Sulfate attack test can be done in many other ways using magnesium sulfate as well as sodium sulfate. So I've just done some literature which is best way to simulate the field conditions. So a few studies said that magnesium sulfate, because most of the, when I was talking to another research scholar who was doing in cement concrete pavements only, then he said he has done both the sodium and sulfate. The funding was available for that person. So for me, the funding was not available to do so many tests. So I just wanted something which is very specific and which is more, which I can relate more to the this one. So from some papers, for some reason, it says magnesium sulfate. So I can tell that, I can defend that, okay, this is from this paper, it is understood that this is the best way, this is better than that, or this has to be done. So something like that has to be done in order to minimize the number of things which you do. So simply you do that, you do this, and then there is no use of doing when it simulates the same condition. The reason behind this is a major source of sulfates. You get sulfur. It can be exogenous origin or endogenous origin. So when I'm talking, so we need to concentrate on both material as well as environment. From material also sulfate can come, from environment also sulfate can come, because due to some industrial, suppose road is pavement is on industrial area, and some water, the industrial waste or the water from agricultural areas, because agriculture, many pesticides are they use, and due to that sulfates may attack, that is sulfate rich environment. And at the same time cement, and same time aggregates. When I'm talking about normal aggregates, there is no much sulfates, but when I'm talking about recycled concrete aggregate, the ethered mortar will have more amount of sulfates, which and the ethered mortar or residual mortar, it's porous in nature also. So there is a possibility of penetration of sulfate into the mix where I'm using recycled concrete aggregate, where they have more water. So that is the reason this has to be studied. So actually, the 1 year study it should be. I've just stopped at 200 days because of during Corona. I had to cast this, and I had to stop because there was no other way to just check the pH of it, or to add more to make it alkali. All those things was not possible. So just stopped at 200 days. So just you can just check out this 15 days, 30 days, 45 days, 60 days, all these duration. I have just checked the compressive strength, how it is varying. So like I can see, if I can say one thing, that if suppose you go for 200 days, I would have got much lesser value here 40. Now I got 40.68. Now I can conclude that 50% is okay to take. But if I would have gone for more number of days, I would have got little less. But I can always say it's an accelerated test. So whatever we get it in the laboratory, maybe it is because it is an accelerated test. You can always say that much more days, the durability is more. Next is this is a discussion. Even I say 100%, they say 30 only, 30.66 Newton per millimeter square. So here you can always improve, because you can use you can remove the motor, and then we can use some kind of pozzolanic material, say example fly ash. When you use fly ash, what is happening? The fly ash has pozzolanic properties. It will go fill the capillary pores which is present in the ethered mortar, and the penetration of the sulfates will be less, and then it can mitigate the effects of sulfate. So it's always possible to use some low cement with low tricalcium element. There is a alternative to limit or to reduce the the sulfate attack, even if you use 100%. But I haven't tried with fly ash because it takes a lot of time, like strength, maybe 56 days I have to do. Okay, wait. So, but always it can be done. Fly ash can be utilized. And the next one is rate of absorption. So it's not the absorption from top. This is a unidirectional. This represents unidirectional capillary rise from one directional flow. This is a test setup. This test is done as per ASTM C1585. So initially 300 mm, 150 mm diameter, 300 mm cylinder is casted. Top 25 and bottom 25 is cut, and then the remaining portion is cut into 3 different samples of 50 mm, 50 mm height. Then conditioned as per ASTM, because cured it for 28 days and kept it in the oven for 7 days. Then again sealed all the sides, and then top and only bottom is kept for the water penetration. This is the absorption formula which I've used. Absorption is equal to change in mass divided by area of cross section into density of water. And then this is the table which represent the sorptivity data. This S1, S2, S3, that is for, this is only for one sample I have done. So I have done this for R0, RJ0 mix, RJ50 and RJ100. So this is just an example of one. Here the test time is from 1 minute to 7 days. So here whatever red mark I have given, that represent primary absorption, and remaining 1 day to 7 days represent secondary absorption. So when I'm talking about sorptivity, we measure sorptivity in terms of primary absorption and secondary absorption. So how do we see this? I hope this is understood. Time I have taken into time I just converted in terms of root, and then I is calculated in the formula which I have showed. So I plotted in the graph. Then from this graph, this is plotted with respect to y-axis absorption and x-axis time. Then from that graph, I just differentiate, just took primary absorption data and plotted here, and then done the regression analysis to get the coefficients. This is done in Excel only because I know this is linear. It has to be linear. Primary or secondary absorption data, when I am plotting, it has to be linear, where the R square value should be more than 9 only. It will be 9 only. So I was very sure that I have a linear data between the time and absorption. So I plotted in Excel only. So this is for 50%, this is for 100%, similarly done for all the data, and then got this initial sorptivity and secondary sorptivity. So here also, see, when I'm comparing, this is very obvious that initial sorptivity will be always more, and secondary sorptivity will be comparatively less. That's because initially some pores will be there in the concrete, some minute or capillary pores will be there. So when it is exposed to water, there will be rapid absorption of water to the pores, so that everything is filled. All major pores are filled. That is why initial sorptivity will be always higher. When I'm talking about secondary sorptivity, it is long time absorption. So whatever is remaining pores, that will be slowly absorbed. So that is why secondary absorption sorptivity value will be always less compared to initial sorptivity. That should be known, because by mistake, if your experiment is not proper, you should be able to analyze the data. So that is why I always say, try to read the paper, understand what is the possibility, what is the kind of outcome, or what is the kind of results you get it, so that you can make out whether you're doing in a proper way, correct way or not. Or if you don't get, you can always repeat rather than presenting a wrong data. So this is the thing, that is why have a good knowledge on what is the behind, what is behind, which should be higher, what which should be lower, all those things. And then this here, if you see RJ0 value, RJ50 and RJ100, compare it this comparatively, obviously the natural aggregates will have uh, more, so this value is less and this here it is more, but always it is possible to use fly ash and then then fill all the capillary pores and then do the sorptivity test. Always you will get a better results than this. So already I said, this is just, you can go through. Initial rate of ingress is observed due to the fact that water has gained access to all the major capillary pores. In addition, rough texture creates more contact points, because we know the adhered motor is rough, texture is rough, and it creates more contact points and pathways interconnected, as same as soil. When we are talking about soil, we talk about the interconnection, connected void. So here also interconnection will be more, and then pathway for water will be more, and then so much porosity is more. So these are the reasons, because of this variation. And the controlling is very important, because of these freeze and thaw damage can happen. So, and then reduced strength can happen, surface deterioration of pavements can happen. So because of these reasons, this test is very important. Next very important test which I have done is this fatigue damage, fatigue analysis. So as you know, this is this is done in 100 into 100 into 500 beam after casting, and this is a raw data. Just having only 15 minutes time, so I'll just go run through the slides. This is the fatigue data which I've got. This is raw data. Okay, I've not modified anything, just a raw data which I've got it from a machine. So I've considered 0.55, 0.65, 0.75 and 0.85 as a stress ratio for all the mixes. And I don't recommend anybody to do only five samples, just because of because I had casted so many number of this many around 10 number of beams for 0.55, say for one stress ratio, 10 number I had casted. But some or the other reason, I could get only 5 points, because all many heterogeneity is there in this particular fatigue analysis. Sometimes it just fails, sometimes it doesn't fail at all. So many, because of many other reasons, I could not take all the specimens data. But I always recommend, whenever you do fatigue analysis, it is always, they say, they not they actually one author, one researcher, his name is OH. He has done a number of studies on fatigue analysis, because when I was doing this fatigue analysis, I had to study a lot of papers, because there are so many assumptions behind it, frequency and cyclic loading and what has to be load, all those things has to be known. So I was not knowing what are the inputs which has to be given. So more background is required to do this particular test. So the best paper, the OH, he has done so many research on this fatigue analysis. So you can refer, anytime you do anything on fatigue analysis, you can refer to the papers by OH. So here they say 24 number of samples are required to get 1 point in a to create a Euler equation. One to create Euler equation, I'll tell you what it is. So to establish 1 point, 24 number of samples are required. Then we can say it is the data is reliable. So that was not possible due to many other reasons, because all these things casted during Corona. So Corona time, that's reason I had to restrict it to 5, just to complete my this degree. So I just converted all the values in terms of log that is required, because the Euler equation and this we get it only when we plot with the x-axis stress level in terms of stress ratio, and the log value in x-axis. So you get this is also done in Excel only because it's linear data. So got a equation, linear equation, regression analysis is done, and the linear equation I got y equal to mx plus c, that equation, that is called Euler equation, which is given in IRC 58 also. So I've just compared, taken the IRC equation, log 10 is equal to 0.9718 minus SR, stress ratio, divided by this. This is when, because IRC always correlation is 1. When correlation is 1, this is the equation which we got. My equation is also equally good, that 0.93, 0.97, 0.96, no issues with correlation, because we will not be able to get correlation coefficient as 1 every time. So wherever it's not bad, 0.9 I'm getting. So the equations developed for all the three mixes which I have used based on only 4 different stress ratio. I know it's the IRC 58 table, if you see, it's the stress ratio ranging from 0.45 to 85. But here just taken only 3 stress ratios because of the limited number of samples available. So for the same reason, I thought I will just stop here initially, because this is enough. Suppose I need to find out the fatigue life for any stress ratio. This equation is more than sufficient for me. So I would have stopped if I would have taken 24 number of samples. But then I did not take 24 now the enough number of samples. I had to do some reliability analysis also in order to establish, tell that it's the fatigue life is the whatever I have done is reliable. So reliability analysis is also done using, there are many techniques to do reliability analysis for fatigue data. Which I have chosen as two parameter Weibull distribution, which is why I have chosen. There is a reason behind there to choose this particular Weibull distribution. It's because whenever you have a less number of data, we go for this Weibull distribution. So in the Weibull distribution, the coefficient is LR. So what I mean by LR, it's a procedure. You Google search, you get this procedure how to do, and developed a Excel program to do this, because there are so many data, so many things, it's not possible. So better always develop a Excel program so that you can just convert all the values from raw data to normal, then again from that to this. So this is a reliability ratio. Reliability ratio means it's a probability of survival system. Reliability LR means it's a probability of survival. When I take 1 by LR in the next formula, it means it is probability of failure. And when I'm taking 1 logarithm here, that means to linearize the data, I'm taking 1 log. And when I'm taking double log, that is to model, to get a probability model. That is why this double, there is a reason behind everything. So when you do something, it's okay, you just do, okay, this is a procedure, you do everything, you finish it off. But it is always, you should learn why we have to go for, okay, I got only this, see the last formula, double logarithm is there. I can just use this double logarithm formula and just complete my work. But it's better always then, so that we'll have a good hold on it, why we are doing this particular, why we are using, how it came. So mathematical background is very much essential for doing all these things. You can always approach your mathematics teachers, because we might have forgotten long back, we have done probability, we have done mathematics. So it's better we whenever we have a modeling, we have to do some modeling, we just better contact some mathematics department people, and then just study the behind, so that you know, when you get a wrong value, you can make out it's wrong because of this reason. So here I value, I have just order in terms of 1, 2, 3, 4, 5 S&D. And this is also in the this order only. The first one is the largest value, second similarly we have to arrange. That is very important in fatigue analysis, arranging in this order. I get LR value, I just calculated everything according as per the formula, and there is a reason for this negative value also. Negative value, when I'm getting a negative value, I should be because when I'm presenting this, people will ask why some are positive, why some are negative. This is again because of not having enough number of data, not reliable. This data which I'm getting, I should have taken some more, and then I should have say I have only 5 data. I should have taken more data. Then I should have after finding out ln, I should have just deleted all this negative values. Negative value says the reliability is little less. Reliability for this particular the data is little less comparatively. So later ln is also, I got some calculation is done. This all done in excel. The program is done in excel, and then again I plotted the graph between this. Then again in this excel only I got linear regression analysis. Linear regression analysis, all the R square value, it's see here it is a little less 0.79, but I had to take, there is no other way, there is no way for me to do the test again. That was not possible. So just taken whatever I got. So here I said it is a 2-parameter Weibull distribution. So when I'm talking about 2-parameter, these 2 parameters are important, alpha and mu value. This is all I know. It's maybe for those who have not done this, or it'll be new for you, but always because it was new for me also. I never thought that I would do some analysis, all those these things I never thought. But then when I took very few data, I had to do this. There is no other way, because I cannot rely on those data. So this has to be done. It's always possible, because if you feel that you have to do something genuinely, if you work, you get some papers. If you think that you won't get papers, and your mind will set up in such a way that it is not possible to do it at all. So if you think that you have to do, because I did not think that I have to do, but my situation was such a way that I had to do this particular Weibull distribution. So I started searching a lot. I think 1 week I searched for the papers where they have done Weibull distribution, searched everywhere and asked many people who have already done. Somehow, with the help of many papers, I just took my values and just did analysis, and then compared with the values which they have. So all those circles I have done, and then finally learned, and then program. Then I have done an Excel program, because otherwise it's not possible to do Excel program. So some experiments have been conducted just to match the data with their value. So somehow it happened. So it's not very big deal if you read some paper and say 5 times, or you don't understand, read again and again, then you will understand the way. It's not very tough to understand. Once you read, you won't understand. Most of us will not understand. Maybe many times you read, you understand this. And the parameter also, this see alpha value, mu value. There is a see mu value, alpha value. You see it's when I'm taking out 0.55, it's only 10.2. When I'm taking about 0.65, it is 3.3. Here it is 1.4. So high stress ratio, the shape parameter is less, and low stress ratio, it is more. Reason for that is also should be I've just found out, because I felt my data are just varying here and there. What is the reason behind it? You just thought of it, and then found out there are 2 terms called alternative stress amplitude and mean stress component. Mean stress component is static, it's constant, but alternating stress component, during fluctuation of cyclic loading, it will change, because fluctuations will happen during cyclic loading. So the difference between maximum and minimum stress is called alternative stress, which is varying, which will vary, which will dominate in the case of this. In the case of low stress ratio, and in the higher stress ratio, the static component will overtake the other one. That is the reason behind this lower value and higher value, and the probability of failure is lower in the case of high stress ratio, and in the low stress ratio, probability is more. That is the reason behind that. Then I've developed I have only 5-10 minutes, I think, just finish off this SNPN relationship also to estimate, that is to estimate. SNPF means probability of failure. what is the probability of failure? Just estimate the probability of failure at given stress level, and then characterize the statistical distribution of fatigue. This I've just done. So this is a procedure for a little long procedure, taking alpha and mu value. Alpha value means it's just a slope from this graph. This graph, alpha value is 5.08, and beta value is 63. From beta value I calculated mu value. Mu is mu, here alpha is directly from graph, mu is a calculated value based on constant beta. So yeah, using those, just done probability of failure. Then then this graph this table says what is the probability of failure at 5%, 10%. That means what is the probability of success? 95% success, 80% success, 30%. So easily we can make out. You do this, easily we can make out what is the probability of failure at different stress ratio. So that we can just plan. This is SNPF relationship for all the mixes is done, and this is calculated fatigue life. From calculated only for 10% probability I have done. Next, this is again got it for just very few graphs I have put. Here it's from my studies, whatever I have, I want to conclude that 50% is possible. So it can happen that 50% is not possible under fatigue. But thankfully, see, the graph is, the black is for RJ0 control mix, and 50 is for, red is for 50%. So it is in line with this in higher stress ratio, but lower stress ratio, it is not getting, not very much matching. For 100%, it is all obviously it is little less the resistance. Again, have some equations to compare the theoretical and calculated. That's all. And then effect. This is also just done. Just some studies. This is just open for those who are doing research on recycled concrete aggregate. Can think of it. I've just given a subgrade, heavy compaction subgrade. The first figure. Second figure, a DLC dryling concrete. Then again the PQC, and using a inserted some thermocouples at some locations. See, these are the locations where I inserted thermocouples to measure the temperature temperature variations, and then I had to take the temperature measurements and then do ANSYS. Thermal statistical analysis I've done in ANSYS, and just giving you a hint so that you can always have this and think of doing such kind of experiments. Then done ANSYS. I think I have just linked. I don't have the file of ANSYS. This is simulation done in ANSYS. And then compared all those things. I'm not just touching because it will take a lot of time. I have only 5-10 minutes now. So compare see, I said you that I will be just showing, because I haven't included this part in my thesis, because the thesis title was the sustainable. So I concentrated more on sustainability than cost analysis. Always it is better to do cost analysis, because we'll have an idea what is the cost benefit and cost benefit method. There are many methods to do cost benefit analysis. This is a simple cost analysis, not cost benefit ratio. All those things I have not done. Only this cost analysis I have done for 0, for 50%, and for 100%. See here, comparing, I get only 11% total savings. In the case of 50%, when I'm replacing 22%, it is 22. When I'm replacing 100%, 22% is savings are there. So that is not very much advantageous, but always it's, but if you do some processing techniques and later even RCA cost will increase. Don't know, transportation cost also we need to include. So that is why I said cost benefit analysis has to be carried out. A detailed cost benefit analysis, if you carry out, you can just but that again depends, transportation and the recycle, what kind of processing techniques and how much they charge all those things has to be taken. So these are the results and discussion already then and there I have told. So from my study, I can conclude that 50 percentage good quality materials can be used. But I don't say that my studies is best, because I have not used any treatment. So it's actually always better to take 100 percentage and then do something which is do some treatment which is cost effective, and then try to utilize 100 percentage materials, because in future we will we will, the demand is more and we will face problems. So it's not that only 30, 50, 70, 80 and all cannot, that is not recommended. I feel 100% should be used in a very sustainable way. Some treatment which cost little less. Whatever relationship I have made, it will help that is just to help some other researchers in understanding the behavior of RCA with some percentage replacement. Effect of cement slurry treatment, it is 10% is considered as yeah, this. So then and there only I've already explained what is the result. That's all. The future scope of the work, yeah, I tried with 2 lift concrete. That means the first, when I'm casting 150 millimeter cube, size of this height is 150 millimeter. I tried using a very good quality natural aggregates for 75, and the remaining 75 with recycled concrete aggregate. Use 100% replacement. So that is still going on. So that also can be taken as a future study, and you can use some techniques called double mixing using fly ash. That mixing time varies. First you some 60 minutes initially, you add this, and 120 seconds, something like some double mixing approaches there by Tom et al. So he has done enough studies using double mixing approach. So that also can be tried to to mitigate the negative measures. And the next, SEM analysis can also be done, because I said IT is at the initial interfacial transition zone. Not I have done some initial studies on done some SEM analysis, but since I have not added any cementitious material or pozzolanic materials, I did not find much difference in the pictures I've got. So I've not added that also. You can always try adding some fly ash or any other pozzolanic materials which is sustainable in nature, and then go for SEM analysis. That will be a good study. And then you can always, if funding is there, it is always possible to have some strain strain gauges and thermocouples or anything. Some field studies can be done. Mine was limited to this laboratory samples. Yeah, that's all. I thank my guide, research supervisor, Rashega sir, for guiding me throughout my journey, and my HOD and my doctoral committee members, all of them who helped me to complete my studies. And I thank Dr. Asha ma'am and all the staff of Mangalam College of Engineering for giving me an opportunity to present my work under this platform. And I know many other staff also might have worked for this successful conduction of this 5 days workshop faculty development program. So I thank all of them. And thank you, ma'am.
Thank you, ma'am. This is time for open discussion. If anybody has any queries, you can ask them.
Hello, excuse me, madam.
Yes, sir.
Madam, actually, this recycled aggregate concrete studies has been done with conventional concrete only, madam. that strength studies, mechanical properties.
Yes.
Modeling analysis, any modeling analysis has been done, sir, madam, for this experimental to model ratio. What is the variation factor should be there?
Yeah, actually, I have what I have done is I'll just show you my slides. Whatever model I have done, I'll show you, sir. Sir, this was my model. 500 mm length and width is 500 mm only. You're able to listen to me, sir?
Yes, madam.
Sir, this is what I have done, the model studies. So the compacted subgrade thickness, depth wise, I kept as such. I did not change because depth wise only the temperature stresses has to be analyzed, right? So depth wise, compacted subgrade is kept as such, and dry leans concrete 150, and the PQC I have varied, but this is just an example. 300 mm thickness. It can be 250, it can be 200, it can be 150 also as per IRC. But here I've just, this figure I've just showed it as 300 mm. And 500 in the laboratory, I have done only 500 mm, 500 mm. Then while modeling, what I have taken this boundary conditions. Geometry of slab considered in the study are 4.5 meter length and 3.5 meter width. That is actually I have actually in the answers I have given 500, 300 also. But when I'm giving that condition, it is the stresses are very, very negligible. So I cannot use those boundary condition which I've used in the field. So this is the actual single lane 3.5 meter width and 4.5 meter length, the minimum length and width which I could give it as the input. And the boundary conditions, you see, the bottom phase of the subgrade is fixed in all the directions. Side phase of PQC, DLC and subgrade is also fixed in Z direction. Z direction means it is in the direction of traffic. And Y direction it is kept free because I want to measure the temperature along the depth, Y depth. Right, depth wise I need to measure, so that is kept free. See here, and one more thing is, here the top PQC, actually according to the boundary conditions which I have given, all the sides of the PQC should be covered with some material so that the heat will not get penetrated from the sides. Only from the top it will get penetrated, so that we can simulate the ANSYS results and the field conditions.
Okay, madam. Thank you, madam. My kind request is to share this PPT, madam, so that it will be useful for research works, madam.
Yes, sir. I will see. I'll try to. I'll just give it to Asha, ma'am. She can share it with you. Yeah.
Okay. One more question,
And
madam. This in the regression analysis.
Yeah.
In the regression analysis, how much should be the variant, madam, for the experimental and the regression analysis, statistical linear analysis?
Sir, while doing regression analysis in SPSS, we give it significance level as 95% confidence level. Because there is an option in if you have done regression analysis in which software, sir? Did you try in any software?
I have not used software, but I have done regression analysis for some mechanical properties using recycled aggregate concrete, madam.
Excel, sir.
Excel only.
Okay.
But
Sir,
according to
yeah, sir, while doing the linear regression analysis in SPSS, there is an option for giving a confidence level. So, and when you might have in traffic engineering, we study so many distributions, not like doing so many numericals in traffic engineering problems. We do, while doing the numericals also, we use tables. So here we don't have tables, we just directly, we get it all the values from software. So there is an option called confidence level. So you can choose it as 95%. That means 5% error is uh, 5% error can happen, sir. That will happen.
Okay. Thank you,
So
madam.
you can always go for that. And plus, what you have to check is R square value. R square value together you will get, sir, for all the 11 curves in one slide, click itself, you will get all the R square value, T test value, F test value. So, and a percentage error also. So the error will be significant, very lesser. You should select the curve such a way that you have maximum R square value, maximum F test value, and maximum T test value, and then the minimum error. So in one table itself, you will get, I'm not able to share the table. You can, if you want, I can just take a screenshot and share it with you. You can just contact me, sir. If you are doing something related to recycle concrete aggregate and you want to use SPSS, you can always contact me. I've given my mail ID and phone number. You can mail me. I can share the ANOVA, analysis of variables. It's called ANOVA. That table I can share it to you, how I have selected based on R square value, T test value, and F test value. All these three should be good. Compare all the 11 curves and then you can select. Where you have one more column called percentage error, that is with respect to the confidence level which you have given.
Okay. Thank you, madam.
Yes.
Reshmaji, good presentation. My name is Dr. Srinivas.
Yes, sir.
Is my voice audible to you?
Yeah, you're audible, sir.
Yeah. Thank you for this excellent presentation, Reshmaji. And one query I have is, you have collected the recycled aggregates from different locations.
Yes, sir.
Did you even check the age of those aggregates? Because age of aggregates also has a bearing on the
Yes,
quality
sir.
of the
Yes, sir.
concrete. So what was the age of the various aggregates or other mixed materials, recycled materials you must have used during specimen preparation?
Sir,
Please.
can you see the slide, sir?
Yeah, I can.
Yeah. Sir, source actually, when I inquired, this is a building, sir. So building, the demolition, already the owner was there in the building. So that is the reason I could ask them and I could understand that it is a 10-year-old building.
Okay.
And then see that is somehow I got it because owner or some other person I contacted and then I got to know the year. Otherwise, it is difficult, sir, to get age. I wanted actually to do a different age because this is very like changes very, see, one is 10, one is 15, one is 20, and one is 5. So actually, I should have got some 70 years or 50 years and 25 years old. I should have checked that. So if somebody can get a 25 years of old building, 50, 100, that would give a better results.
Yeah, when the age is very wide, then comparison maybe, as you said, and I also think the same.
Yeah,
The
that
comparison
has
is
to be
much
done,
better.
sir. Yeah, because from my studies itself, I understood that 5-year-old demolished cement concrete pavement is giving a better results than all the other. But I cannot say that age is it's because of age. You see
Yeah,
all the
because
other, sir, you
yeah,
see all source 1, source 2, source 3 and 4. It's all buildings. And the fifth one is a cement concrete pavement, 5 years old. So it can be due to, because it is a pavement. And
yeah,
I cannot say, no, it's because of less age.
yeah. Because I also have a point there, because pavement aggregates, they take a different kind of loading. They take repetitive loading,
Yes, sir,
and the building
repetitive.
aggregates, they do not take repetitive loading. So
Yeah,
the
yes, sir.
extent of fatigue the pavement aggregates undergo is the magnitude of damage which the pavement aggregates undergo
Yes,
is different. The kind of
yes, sir.
loading the pavements aggregate undergo is different from the loading loading the aggregates undergo for a building aggregate.
Yes, sir. It is
So,
entirely different. So actually, I wanted to study. My guide actually wanted to study this in detail, but the problem for this is my objectives were already defined with respect to the type of the experiments which I have to do. Say durability, fatigue, everything I had to do. I cannot take from different sources and then do that, because that will not give any good value. That is the only reason I stopped this in between. So I feel somebody should take uh, only this as their project, only mechanical properties but different ages and
I'm
different
also
types.
trying. Yes, madam. I think
Yeah,
I'm
different,
also.
as you said, sir, different the type of the fatigue, because repetitive loading in the case of cement concrete pavement,
Exactly,
there it is
exactly.
different loading. So that can
Correct.
also taken as a study. So that's I actually wanted to do but could not collect. It's a very big process, collection and coming. I mean, taking from the field and
Exactly.
transportation, because this transportation,
Exactly.
this construction and demolition waste transportation, many people are not ready.
Correct. There are some
Yeah,
guidelines also for that.
yeah,
Yeah.
guidelines are there, no? So they're not ready to take. So I had to just cover with the 2-3 bags, I mean, and then somehow give more money for transportation. That's why.
Yeah, one of my master students worked in that area also. So we actually trying to develop. So I'm trying to get more
Yeah,
insight into your
yes, sir,
presentation.
that has to be done because it's a because nobody, not much, many people touched on that.
Correct. Thank you
Yeah.
for giving a good presentation. Thank you to
Thank you, sir.
organize it.
Yeah.
Yeah.
Any other questions?
I think no more questions.
Yeah,
Thank you very much,
if
Rashma
ma'am,
ma'am.
if anybody wants to ask, because may not be comfortable to ask in this platform, so anybody wants to ask any questions, can personally mail or message me. I prefer mail, because sometimes call, if you call me, I may not, might miss the calls also. You can just mail me so that I will answer if I know. And I think, ma'am, this is my first presentation for like some colleges in Kerala, because I have been presenting only paper presentation. All those things I've done only in Karnataka. Uh, so very happy that happy to give. I mean, thank you for giving an opportunity.
Thank you, ma'am. It was a very informative session, especially to the research aspirants. Your valuable suggestion will definitely help us, all of us, while pursuing the research. We are very happy to tell you that many participants has requested slides of your presentation.
Yeah, I'll
Ma'am, your
share it
open-hearted
with.
approach to research is a great motivation to all of us. We wish all the best in your future career and let you reach higher levels in your profession. Thank you once again. I once again thank you from on the behalf of Civil Engineering Department of Mangalam College of Engineering. Thank you for your time and
Ma'am,
effort.
ma'am, one more. Yeah, thank you, ma'am. Thank you so much for your words. Glad that everybody, I mean, most of it was useful. And I want a screenshot, ma'am, because I need to just, because some reports, all those things are required. No, when I'm giving some presentation, report has to be given to I mean, department. So, can I have a screenshot of the presentation?
Yeah, ma'am, sure. We will share it.
Yeah, I think I can also take. I'll just the participants. I hope nobody is just take a screenshot. You can also send me, ma'am, from your end. I just take a screenshot.
Yeah, we will share it.
Yeah. Thank you, ma'am.
Thank you. Thank you. And thank you to all the participants who have attended this section. Thank you and have a nice day.
Asha ma'am.